Welcome back to Larry's Classroom. Today we're going to be talking about decimals and the decimal number system and such. We're going to put a number up here. 7362, which you probably recognize as 7,362. And I'm also going to put a decimal point on that. So if we work from right to left on the decimal place, we have what we call placeholder values. The first digit is the ones place. The second digit moving to the left is 10 times as many, or the tens place. The third digit moving to the left is 10 times more than the one prior to that. That's the 100ths place. And we move one more to the left, we have 10 times increase again, and we have the 1000ths place. So what does this mean? This is equal to 7,000 plus 300 plus 60 plus 2. And here you can see the 2 is correlated to the ones place. The 60 is correlated to the, let's draw this a little bit differently here. I guess we'll stick with that. This is to the tens place. Make a different color here. The 300, there's the 100ths place. The 7,000 is the 1000ths place. And that's how we get 7 times 1,000, 7,000. 3 times 100, 300. 6 times 10, 60. 2 times 1, simply 2. So that's the way the numbers add up with place values. Now we're going to talk a little bit about the numbers to the right of the decimal place. I'm going to put a 0 here, and I'm going to go point. Let's go 762. This is what we call a decimal fraction. Everything to the right is a fractional part. And we have the first place, we call that the 1/10ths. This one we call the 1/100ths. This one we call the 1/1000ths. And we're going to analyze this in a little bit more detail. We're going to start with if we have just 0.7, we have one number to the right of the decimal place, and for the fractional portion, we evaluate our placeholder values moving from right to left. Well, we said that this was the 1/10ths place. What does that mean? That means that the denominator of the fraction is 10. This is the same as 7 over 10. Make that a little bit clearer. 7 over 10. We notice we have 10 in the denominator. We have one digit to the right of the decimal place. We have 1 0 in the denominator. Get another 0.76. And we said that this is the 1/100ths place. Well, that's equal to 76 over 100. And you will notice that we have a denominator of 100 to match up with what we called the 100ths place. And you will also notice that our denominator has two zeros, which matches up with the two numbers that were to the right, 2 digits that were to the right of the decimal place. And this, we're going to do one more, 0.762. That's going to be 762 over 1,000. And we called that the 1/1000th place. You will notice we have 1, 2, 3 digits, 1, 2, 3 zeros in our denominator. Our denominator is 1,000, which matches with the fact that we called that the 1/1000th place. We'll work our way back here. We had 1, 2 digits to the right of the decimal place. We had 1, 2 digits in our 1, 2 zeros in our denominator. 3 digits, but 2 zeros, and that was the 1/100th place. The first one, we had the 1/10th place. We had a 10 in the denominator. We had 1 digit to the right of the decimal place. We had 1 0. 1 0. 2 zeros. 3 zeros. And we're going to 1 digit to the right of the decimal place. 2 digits to the right of the decimal place. 3 digits to the right of the decimal place. So to convert a decimal fraction into a regular decimal, all we do is take the number, put it over 1 plus the number of zeros that we have digits. 1 digit, 1 0. 2 digits, 2 zeros. 3 digits, 3 zeros. So this is kind of how we look at the fractional portion, the decimal fraction. The part to the right of the decimal point is a fraction. We looked at a few minutes ago, the part to the left of the decimal point is a whole number. We're going to take a number here, 6.3. The decimal number with a decimal fraction. We have a whole number here, fractional portion here, fraction, whole number. Remember when we talked a few minutes ago about the last lesson about mixed numbers? This really is a mixed number. 6.3 is the same as 6 plus, we take the fractional portion, 3 over, what was our denominator? It was 1/10, a single zero. So this 6.3 is exactly the same as 6 plus 3/10, or we could just write it as 6 and 3/10, which is the common way we write these things. So really, the decimal fractions really work no different than any other fraction. We just are limited in what denominators are allowed, which gives us kind of a nice, convenient formula to work with. And basically, our denominators are 10, 100, 1,000, 10,000, and so on. We just keep increasing the denominators by 10, depending on how many digits we have to the right of the decimal place. And that's 1 digit. Digits to the right. To the right of decimal. 1 digit, 2 digits, 3 digits, 4 digits. That's how many digits we have to the right of the decimal place. We see the number of zeros matches up exactly. Our denominator increases by 10 every time we add an additional decimal place to the right of the decimal point. We'll look at one more before we move on here. We got, here's a decimal number, 17.643. So what does this mean? This is our tens. Tens, ones, 1/10ths, 1/100ths, and 1/1000ths. So let's lay that out in maybe a little bit easier to follow format. Being we have 1 in the tens place, that's equivalent to 1 times 10. 7 in the ones place, and these all sum up, 7 times 1. A 6 in the tenths place, that's 6 times 1/10. A 4 in the hundredths place, that's 4 times 1/100th. And a 3 in the 1,000ths place, that's 3 times 1/1000th. So now let's do the little multiplication here. 1 times 10 is 10. 7 times 1 is 7. Plus 6 times 1/10 is 6/10ths. Plus 4 times 100th is 4/100ths. Plus 3 times 1,000ths is 3/1000ths. So now we've converted every one of these digits in this number to their mean. This was 10, this was 7, 10, 10, 7, 7, 600, 6/10ths, 6/10ths, 400ths, 4/100ths, 3/1000ths, 3/1000ths. So we've converted every digit into its meaning in a whole number or a fraction. Well, we can easily add these whole numbers together. That's 17 plus 6 times 10 plus 4 times 100 plus 3 times 1,000, or 3 over 1,000, 6 over 10. Now we have a whole number plus a bunch of fractions. We notice that these fractions have different denominators. We need the same denominator to add fractions. Well, let's see, 17 plus 6/10ths. If we multiply tenths, we're going to put a 100 here. This thing by 100 on the numerator and the denominator. Well, that's becomes 600ths. 600 over 1,000. You can see that that's the same as 6/10ths. This guy, we're going to multiply the top and the numerator and the denominator by 10, because it's already 100. 4 times 10 is 40. 10 times 100 is 1,000. And this one's already in thousands. So now we have a whole number, plus we have 3 fractions, the same denominator of 1,000. So that's going to be equal to, in mixed number format, 17 plus 6,000ths, 600,000ths plus 40,000ths plus 3,000, same denominator. 600 plus 40 is 640, plus 3 is 643. 643 over 1,000. So we've converted this number. We went through all the place value meanings. We've converted it to a whole number plus a series of fractions that have the same denominator. We've added up with 643 1,000ths. course, the 17 was very easy to deal with to start with. The whole number portion was 17. The decimal point is like the plus part in the mixed number, kind of like an addition. And remember here, 643, we have 3 digits. The denominator is 1 plus 3. There's 3 digits to the right of the decimal place. The denominator is 1 and 3 zeros. And you notice that this and this have the same number, which we could also write this as 17,640 1,000ths, because we usually don't need to put the plus in there when we do a mixed number by convention. So we've taken this number, we've analyzed the meaning of every digit, we've converted it to a sum, we converted the fractions to a like denominator, we did the addition, we ended up with the very same value, the very same meaning. So we're going to shorten just a couple of these. We'll just do a couple of them very quickly rather than doing the full analysis of them. 7.4. That's equal to 7. Oh, I want to write 7, not 4. That's equal to 7. And the fractional portion is 4, 1 digit, 1 0, 4 tenths. 3.75. That's equal to 3. And we have a 75. What's our denominator? We have 2 digits to the right of the decimal place. We have a 1 and 2 zeros. 3 75 100ths. These are the same as 53.241. The 53, the whole number portion, the portion to the left of the decimal plate, you're probably pretty used to using. 53, our numerator of our fraction is 241. Our denominator fraction, we have 3 digits to the right of the decimal place. It's 1 and 3 zeros. So 53 and 241 thousandths. 7.4 is the same as 7 4/10ths. 3.75 is the same as 3 and 75 100ths. 53.241 is the same as 53 and 441 1,000ths. So that kind of covers how our system of decimal numbers work. We're going to talk about how we add decimal numbers. I'm going to give you 3 decimal numbers. 8.25 plus 5.07, and this is going to have a subtraction, add and subtract actually, minus 10.3. So we have 3 numbers, decimal numbers with decimal places. We're going to first start by drawing 3 decimal points on the board here. They're all lined up. Take the first number, 8.25. The second number, 5.07. The third number, 10.3. And that one's subtracted. The others are added. Now the object, this will become automatic after a while, but the object of lining these up like this was to make sure each digit was only being added to a digit of its same place value. 5 and 7, that's 12, but it's actually 12 100ths because it's in the hundredths column. We carry the 1 just like we've always done in addition. 1 plus 2 is 3, plus 0 minus 3 now, because these 2 are added and this was subtracted. So we got 3 plus 0 is 3 minus 3, so we get a 0 here. We go to the next column. 8 plus 5 is 13, minus 0, there's a 3. We carry the 1, but 1 minus 1 is 0. And we don't really need to write down the leading 0, so we can just eliminate that. So what we've learned is 8.25 plus 5.07 minus 10.3 is equal to 3.02. And we put the decimal places in there just to make sure that we're in a vertical line, just to make sure that we have each digit lined up with the digits of its same place value. 100ths in this case, 1/10ths, ones, tens. And they expand this way to the right. 1/10ths, 100ths, 1,000ths, 1/10,000ths, 100,000ths, so on, and they expand this way to the left. Ones, tens, hundreds, thousands, 10,000ths. Now we could have taken this thing, if we got a little more practice, we wouldn't have needed to write all the decimal places in there first. We're just careful. We go 8.25, 5.07, 10.03, and that's subtracted. The other two are added. We usually don't put the plus sign, though we could. We usually assume plus when we're lining them up like that for the ones above. Well, let's just put it in here, just to match that up. But you notice we did the same thing we could write out the numbers as long as we keep the decimal place lined up, we're good. That way we're adding and subtracting tenths and hundredths and thousandths rather than adding tenths to hundredths and such. Now we're going to talk about doing a little bit of multiplying with decimal numbers. We're going to do some simple examples. Suppose we have 0.1 and we want to multiply that times 0.03. Well, for a simple one like this, we're just going to go 1 times 3. That equals 3. And now we're going to count the decimal places up here. We have 1 decimal place there, and we have 2 decimal places there. 1 plus 2 equals 3. So we have 3 decimal places. We've added the whole numbers. We have an implied decimal place here, decimal point here, but we want 3 decimal places, so we got to move over 1, add a 0, move over 2, add a 0, move over 3. So this becomes 0.003. So now we have 1, 2, 3 decimal places in our answer, just like we had 1, 2, 3 decimal places total in the original problem. Which is, when you convert these to whole numbers, you got to remember that you got to have the same number of decimal places in your answer as the total that you had in your 2 factors that you were multiplying. The 2 numbers that you were multiplying. We're going to quickly talk about precision. We'll talk more about precision in coming lessons, but 0.20 is equal to 0.2. Well, it is, but basically this number is more precise than that number. There could be a 1 or a 7, or there could be a 1 or a 2 or a 3 or a 4 or a 0 out there. We don't know what's in that column because we only went out this far. This one, we went out one more column, one more digit to the right, and we're showing that it is a 0. So we know the value of this number slightly more precisely when we know the value than we know the value of this number. Though for simplification, for right now, these are the same number. Now we're going to do another example of multiplying decimals. 0.20 times 0.42 times 0.3. Now, being this 0 is only for precision, and we'll get more concerned about precision as we move along here. The best way to keep track of the decimal places here is just get rid of that 0. Don't count it. So we have 1, 2, 3, 4. 4 decimal places. It's total in our problem. So we're going to want 4 decimal places in our answer. Now let's just do it like whole numbers. 2 times 42 times 3. Which you work that out, it ends up equal 252. Now 252 is not the answer to our problem. That gives us the digits we need, but we need to have 4 decimal places. So let's write that 252 down here. And there's an implied decimal place right there, because there was one here, one here, one. Always when you have no fractional part, there's an implied decimal point. We don't need to write it down, we're just dealing with whole numbers. But there is an implied decimal point right there. And we need to move that 1, 2, 3, 4. 1, 2, 3, 4 places to the left so that the number of decimal points in our answer is equal to the total number of decimal points in our problem. So we've got to put a 0 here to accomplish that. So what we end up with is 0.2. I'm going to put this 0 back in because it represented precision, but we didn't use it to determine decimal points. Times 0.42 times 0.3 is equal to 0. We're going to put a leading 0, which just helps offset our decimal point here. 0.0252. Now I erased the 0 up here originally just to make it easier to keep track of counting our decimal points. I put it back in here so it looked more like the original problem. And what it amounts to is counting decimal points. And we're talking about the fractional portion, which is the portion to the right of the decimal places, not points, decimal places. And we're talking about the fractional portion of the problem, which is the portion to the right of the decimal point. Do not count trailing zeros. And that's why I erased this one, so we wouldn't mess up and accidentally count it. That's a trailing 0. Trailing zeros are only zeros that appear to the right of the last non-zero digit. Quick example here, if I have 0.203, this is not a trailing 0 anymore because we're ending with a non-zero digit. If I have 0.2030, now this one is a trailing 0. So trailing zeros will have no other numbers but zeros to the right of them. Okay, we're going to do another example. I don't like that pen, it ain't working very good. I'll use this one. 0.2 times 0.2 times 0.04 plus 0.011 equals So here we have, we're going to multiply and we're going to add. And if you remember our order of operations, we had parentheses. We had divide. And we have add, subtract. And I'll put some numbers on those. This is the first we do. This is the second we do. This is the third we do. So we have a multiplication, we have addition. We see that mult and divide is done before addition and subtraction. So just not necessary to do this, but just to help us keep our eye focused on what we want to do first, let's put a parenthesis there. So let's do that part in the parentheses. So let's count the number of decimal places first. We have 1, 2, 3. We had one decimal place in this number. We have 2 decimal places in this number, but 1 plus 2 is 3. I just want 1, 2, 3. So we have 3. We're going to need 3 decimal places in our answer. So let's do 2 times 4, and that equals 8, right? 2 times 4 equals 8. We've multiplied the whole numbers in these 2 decimal numbers times each other. But 8 is not our answer. We need 3 decimal places. So we're going to go put the 8 here. And we're going to move over 1, 2, 3. And we're going to put our decimal place right there. And now we're going to put a leading decimal just to offset the decimal point. But 0.008 and 0.008 are literally the same number. But this extra 0 just offsets the decimal place, helps our eye focus on it being here. But we'll notice we have 1, 2, 3 decimal places, just like the total of the number of decimal places were in our problem up here. So now we've done the first part. We have 0.008, which we could call 8 1,000ths, plus 0.011, which we could call 11 1,000ths. And we could say that 8 1,000ths plus 11 1,000ths is going to be 19 1,000ths. That's one way to look at this problem. But let's go back to how we added decimals. Let's line up our decimal points and write the first number in, 0.008. Write the second number in, 0.011. And this is a plus. 8 and 1 is 9. Nothing to carry. 0 and 1 is a 1. 0 and 0 is 0. Bring down our decimal point for our answer. 0 plus 0 is 0. Bring down that 0 just to help our eye offset the decimal place. So we ended up with this was equal to 0.019, which is also equal to 19 1,000ths. Though for convenience, the decimal numbers work nicely with calculators and stuff. We're probably going to be doing a lot of work with this format. The reason I put this up here and this up here was just to demonstrate that they are the same number. But when we're talking about decimals, we're generally going to be using this format. But like everything in math, they need to be consistent, and these fractions and these decimals are consistent. And if we found inconsistency, we'd have to look a little bit about what's wrong with the way we're doing this. Okay, we're going to talk about dividing of decimals. I'm going to write a division problem up here. 0.138 divided by 0.119 0.12. We want our divisor to be a whole number. Now, we've talked about this being the same as a fraction, so I can rewrite this as 0.13. Let's put this over here a little bit. Erase this. I'm going to rewrite this fraction, this division problem, as a fraction. 0.138 divided by 0.12. And now why did I do that? The reason I did that, remember, if we multiply the numerator and the denominator of a fraction by the same number, we do not change the value of the fraction. We end up with an equivalent fraction. So I'm going to do that here. 0.138 times 100, 0.12 times 100. And again, I've multiplied what I like to call a fancy 100 over 100. But we can multiply by 100 simply by moving the decimal place to the right 2 places. So 0.138 becomes it becomes 13.8. See how we moved the decimal place 2 places, got 13.8. And this becomes 12. Again, we moved the decimal place 2 places to match the multiplication by 100. So we've got 138 over 12 is the same as what we got here. And I did this to demonstrate why it's okay to do what I'm going to tell you next. We want this to be a whole number. Well, 1, 2 decimal places will make that a whole number. So we want to move this 1, 2 decimal places as well. Well, if we put a new decimal place right there, we end up with 13.8 divided by 12, which is the same thing we had over here. This was just more to demonstrate why it's okay. We're multiplying the numerator by 100 and the denominator by 100. But this puts our divisor into a whole number, which we want before we do the division. So now we can go 12 into 138, or 13.8, using the long division. 12 goes into 13 one time. We multiply 1 times 12, we get a 12 here. We subtract. The 8 minus 0 becomes still 8. The 3 minus 2 becomes 1. Bring our decimal place up here so they match. Now 12 goes into 18. That goes in there 1 time. 1 times 12 is 12. We subtract. 8 minus 2 is 6. 0. 1 minus 1 is 0. We add a 0 so that we can move over. 12 goes into 65 times. So we end up with this original problem is equal to 1.15. This is equal to 1.15. 0.138 over 0.12 is equal to 1.15. You can punch this in your calculator if you desire and check it out. But this is how we would do it longhand. We would need to convert this into a whole number, which isn't necessary to do it on your calculator, but the calculator will keep track of that for you. But to do it longhand, we convert it into a whole number. We do the long division. We get the same answer as our calculator will give us just by punching in the numbers. We're going to do one other example, and we're trying to show how you work with decimal numbers, and you're probably noticing that it's actually pretty similar to working with the whole numbers. Same rules apply. We just have a few more details to look at. So we're going to write up another problem here. 1.5 times 0.04 over 1.2. What's that equal? Well, we have multiplication, we have a fraction bar at x that indicates division. So I'm going to rewrite this problem just to illustrate where the multiplications and the divisions are. We have 1.5 times 0.04 just times the numerator divided by the denominator, 1.2. Another way to look at this might be to realize that this is 1.5 over 1. We can always put a number over 1, convert it to a fraction, times 0.04 over 1.2, which basically becomes 1.5 times, we're multiplying across the numerators, times 0.04 over, multiply across the denominators, 1 times 1.2 is just 1.2. So we have 1.5 times 0.04 divided by 1.2, 1.5 times 0.04 divided by 1.2. Now again, order of operations, we only have multiplication and division. Multiplication and division have the same precedence. We do them left to right. We go from left, we find the first multiplication, we do it, and then we replace that with a number. Then we go left to right again, we find the next multiplication division, we do that. Just to help our eye see it, I'm going to add these parentheses here again on the first thing I want to do, which you don't have to do. It's a step to help your eye look to the right place. So we're going to do this piece in parentheses. 1.5 times 0.04. Well, first let's count our decimal places. 1, 2, 3. So we're going to need 3 decimal places in our answer. And now we're going to do it like whole numbers. 15 times 4, which basically equals 60. But we need 3 decimal places, so we got to go 1, 2, 3. So we put it 3 decimal places. I'm going to put the leading decimal place to the left of the or leading 0 to the left of the decimal place, just to offset our eye. So we can replace what's in parentheses here with 0.060. And we're going to divide that by 1.2. So we've done this first multiplication that we came to left to right format. Now we're going to do divide. We want to make this into a whole number. We're going to do that by moving the decimal place 1 to the right and this one 1 to the right. So it becomes, I'm going to put a different color for that new decimal point. The new decimal point, I'll put a different color here just to make it easier to see. So we've come up with, instead of 0.060 times 1.7, we now have 0.60 times 17. Oh, that's divided by. Excuse me, divided. We're still dividing, we're not multiplying. Where did I drop something? Oh, this is 12. Like 12. That's what. This was a 2, not a 7. Okay. That's a 2. Same color. A 2. I copied my number down wrong. That's why it doesn't look right on my. So we're dividing by 17. We're dividing by 12. By 12. By 12. Erased it and then wrote the same wrong thing right back in there. 1.2. 1.2, multiply it, moved it 1 point to the right, we got 12. So now we're going to do our long division over here. 12 into 0.060. Put our decimal place into there. 12 does not go into 6, but 12 does go into 60, and 12 goes in 65 times. 5 times 12. Erase these lines I put here. 5 times 12 is 60. We do the subtraction, 0. We have no remainder, we're done. So the result of this is equal to 0.05, 5/100ths. So we took this original problem, we did the multiplication first, then we found that to be 0.060, then we did the division. We found the result of the division to be 0.05. So we have done the complete problem. We've demonstrated how it's really like any multiplying of fractions, and compared that to the order of operations that we use down here. So we got another little more complex example to go through here. First, let's talk for a minute about counting zeros. Here's a number, 0013.48900. When it comes to the value of the number, these leading zeros to the left of the decimal place do not change the value of it. The trailing zeros to the right of the decimal place do not change the value. So basically, we don't count these zeros here when we're thinking about how many decimal places to put into our multiplication or whatever after we've done a withhold number situation. We really only count 1, 2, 3, and you've seen this in our examples. For doing the calculation, when you're not so concerned about thinking about the precision, the easiest thing is just to erase that and not have it there to confuse you. As we go further along precision, that will mean more to you. Now here, 103.2070. We got no leading zeros here. This zero that's embedded in the number counts. We have a single trailing zero. This is not a trailing zero. It's embedded within the number. It has to stay there. It's easy to mess up on counting these zeros, so kind of think carefully about that when you're doing your problems, and put a little extra effort into making sure you don't mess them up. So we're going to start with a problem. It's going to look like this. Here's our initial given to us problem, 0.0030 minus 0.0020 over 0.5 times, in parentheses, 0.05 minus 0.01. We want to evaluate that and see what it equals. Now, you may remember we said the fraction bar was like a parentheses. So to keep us from forgetting, now this is a step you don't have to do, but it might help your eye focus on the right portion to do. I'm going to put some parentheses over the entire around the entire numerator and around the entire denominator, just to emphasize the fact that that fraction bar does the same thing as a set of parentheses. So let's do this innermost parentheses first. Well, 0.05 minus 0.01. If we line that up, 0.05 minus 0.01 is equal to 0.04. Now we probably could have recognized that as 5 100ths and 1 100th and realize that 5 100ths minus 1 100th is 4 100ths. But it's always good to practice the more formal way of doing things initially. So we're going to rewrite the problem. Now we're going to replace this with what we got here. I'm going to leave these extra parentheses on here. 0.030 minus 0.020. Put the fraction bar 0.5 times, which is actually 0.4. And now it really doesn't matter. Parentheses separate things out, so we can do this parentheses first or that parentheses first. Let's just do both of them in one step. So we're going to go 0.030 minus 0.020 0, 3 minus 2 is 1. We get 10 1,000ths, and if we recognize this was 31 thousandths, this is 21 thousandths. Not too hard to see that 30 minus 10 is in fact, or 30 minus 20 is in fact 10 1,000ths. But we're going to replace that with this 0.010, or the 10 1,000ths. Now let's do this multiplication. Well, how many decimal places? 1, 2. We're going to have 2 decimal places in our answer. 5 times 4 is 20. We put 2 decimal places in that. We start 1, 2. So that's equal to 0.020, or 0.20. So we've 5 times 4 is 20. Let me check. Yeah, 0.2. Yeah. This ends up being 0.2. And we could drop the trailing. Let's go ahead and, in this case, drop the trailing. Well, let's not. So we can replace this with 0.02. 0.20. Now this is, we said before, 0.010. Okay, I have a mistake here. I see my problem. I knew something wasn't coming out right. This is not, this is 0.04. So we actually have 3 decimal places here. So 5 times 4 is 20. Copied my number down wrong again. Five times 4 equals 20. We have 1, 2, 3. So we got to move this over 1, 2, 3. So put a decimal place there. I'm going to put the leading 0 to make it 0.020. So let's put the right number there. 0.020. Now before I do our division, let's drop these trailing zeros. It impacts our precision, but it doesn't impact how we do our calculations. So let's drop those trailing zeros so we have lefts to keep track of. We want our divisor, which is the denominator of our fraction, to be a whole number. So we're going to multiply the top and the bottom by 100. We're going to move the decimal places 2 places each to the right, which becomes, if we move this over 2, I think I might have dropped a, yeah, I think did I do this one wrong now? 0.5, 0.4, 0.5 times 0.04, 3. Okay, I dropped a 0 here. Okay. I had 2 zeros, so this one, let's redo this piece right here for the numerator. So yeah, we had 30 10,000ths minus 20 10,000ths, we end up with 10 10,000ths. So So there's where we were. Now we're going to drop our trailing zero to make things easier to keep track of. And now we're going to move this both decimal places 2 to the right to get a whole number divisor. Well, 2 to the right here becomes 0.1, and 2 to the right here becomes 2. So we have 0.1 divided by 2. So we're going to do the division here, long division. You could do this on your calculator pretty quick and easy, but we're going to do it this way. 2 into 0.1. Move that decimal places up to line them up. 2 goes into 1 0 times. So put the 0, we subtract, we end up 1. We add another 0, making it 10. 2 goes into 10 is 5. 5 times 2 is 10. We subtract, we get 0, our remainder 0 is done. So this is equal to 0.05. This was equal to 0.05. And after I corrected my mistakes, we started out with a problem that looked like this. Remembering that the fraction bar works like a parentheses, we drew some parentheses in just to keep our eye focused correctly. Then we did this innermost parentheses in the denominator portion. 5 100ths minus 1 100th, we got 4 100ths, and then we carried the problem down, replacing that with the 4 100ths. Then we did the multiplication, which we found to be whole numbers. 5 times 4, 20, but we had 1, 2, 3 decimal places, so we ended up 0.02. Which we wrote over here. I'm going to put it back in there. Then we did the subtraction in the numerator. 0.0030, 3 10,000ths minus 0.020, 10 10,000, 20 10,000ths, got 10 10,000ths. So we put the 10 10,000ths here to take the place of the numerator. This 0.002 or 20 100ths to take the place of the denominator. Then we erased these trailing zeros just so they didn't confuse our eye. Then we moved both decimal places in the numerator and the denominator 2 to the right, which was equivalent of multiplying the numerator and the denominator both by 100, which multiplies the whole fraction by 1, which doesn't change the value. So moving 2 places to the right gave us a 0.1 here. 2 places to the right gave us a 2 in the denominator. Then recognizing that a fraction is a division problem, we did the divide, 2 into 0.001, did our long division, we come up with 0.005 for our answer to our originally kind of confusing problem, which is this 0.05 is 5 100ths. Whole number part 0. Anyway, I think that kind of covers a good introduction to the decimal number system, how the place values work, how to multiply and divide decimal numbers, review the order of operations and how we apply that to a problem. And as always, I recommend you find a book that you can do practice problems on. If you need practice problems to become decent at math, you don't want to, if you don't practice, you won't remember. Anyway, be sure to like and subscribe, and until the next time, keep on learning.